Okay, we're back to do the symmetric property of congruence. Now, again, we're already assuming that we have this symmetric property of equality. We're just going to use that kind of already established fact along with the definition of congruence to prove that there's a symmetric property of congruence. So we're using deductive logic. We're taking some already proven things, already established, in this case, properties, definitions, and we're putting them together to come up with new conclusions, which would be new properties of congruence. So just like we talked about when we talked about deductive reasoning, this is our deductive reasoning system here. So in this case, symmetric, given, we're going to start with two things that are congruent. Two segments are, we're going to start with two segments that are congruent, and we're going to prove that we can just state the congruence the other direction. Okay, now again, that might seem like that should be obvious, like, well, of course they're going to be congruent either way. But let's assume for now that that's not obvious. We could still prove this using this property and this definition. We can get this new property. Okay, so, and again, this is our bridge between equality and congruence. So we're going to do statements and justifications. Okay, and again, when a proof, we always start with the given. So some segment AB is congruent to some segment CD, given. Okay, now if we can get to this statement logically, then we're done. So that's kind of the last one we want to have. The last statement is going to be this proof statement. If we hit get there and we can justify it, we made it. Okay, so the first thing we're going to do is we're just going to think, well, what does it mean if two segments are congruent? If two segments are congruent, their measures are equal. So we're kind of like going to use that ruler postulate again in a way to say that we know that these two segments have some measurement that goes with them. We don't need to write that out this time. We can kind of just jump to the next statement, which would be, well, that means AB is equal to CD, right? And how do we know that? That's the definition of congruence. If two, and that's kind of embedded in that definition. The ruler postulate kind of is embedded in the definition of measurement and what is a measurement. So if you say that two segments are congruent, you say their measurements are equal. Okay, so def of cong. Definition of congruent segments in this case. We'll do angles again later this week. Definition of congruent segments. Definition of congruence. Okay, from here what we can do is we can say, well, that means CD is equal to AB, right? Because we have this symmetric property of equality. We're trying to prove a symmetric property of congruence, so we can't just use that, but we can use this one. This is like already established. So we can say, okay, you're not going to give me the property of congruence? Fine, I'll just switch to equality, use my property of equality, and then I'll switch back to congruence. So in this case, the reason for doing this is I have a symmetric property of equality that allows me to do this, right? And now I can switch right back to congruence again. So that means that CD is congruent to AB. Why? Because of the definition of congruence, right? If two segments are equal, then that means they have to be congruent because that's what congruent is. So we do another definition of congruence. Okay, that may not seem like earth-shattering. You're like, wait a second, that's like a pretty easy proof. Yeah, we use the definition of congruence along with the property of equality that we already have to get the property of congruence that we want. And we're going to do something very, very similar to transitive. So that's pretty much it. It's just a 4-line proof here. And again, that might not be like earth-shattering, but it just shows how we can take an idea and put it together with deductive logic in like a step-by-step arguments to get a new property or a new definition.